Hello all, welcome back to my YouTube channel all about VLSI. In our previous sessions, we were basically discussing about this linear phase shift, linear feedback shift register, where we were discussing about this particular block diagram and we were having some analysis of how this particular circuit is basically performing CRC calculation and all. If you haven't watched it, then I recommend you to please watch that so that this is the continuation of that particular series. Now, over here, previously, we took the data as 1010, that is 1234, 4-bit data. So it was taking 4 cycles for our redundant bit to be generated. Now, let's say if our data is some 10-bit, let's say if our data is 10-bit, then we are going to basically take 10 number of cycles for getting our result. And let's say if our data is 32-bit, that is 4 byte, then we need at least 32 cycles for getting our final result, right? So basically this is and when we are working with ethernet, we are going to deal with some gigabits of data, and it's not possible to use this kind of circuit which is working on a single bit operation, right? So for that, we are going to check for other kind of architectures, and one of the architecture is parallel CRC implementation, which is basically unrolling or combinational CRC. This is basically most widely used in CRC architecture in modern ASICs, FPGA, and Ethernet MAC, and DMA engines and all. And because modern buses are always wide and high speed. And why serial CRC had a problem? Because we have seen that it is basically processing 1 bit of data per clock cycle. And if we are going to have 32-bit packet, then it is going to require 32 clock cycles, right? And this is very, very slow for 10G Ethernet and PCIe Gen 4 and Gen 5, right? Now, that's the reason we are going to move to other kind of CRC architectures, which is basically parallel CRC. Now, in the case of my parallel CRC, I'm going to process entire 32-bit word in a single cycle. Okay, so that is my basic idea of implementing this parallel CRC. And this parallel CRC is nothing a new concept. It is basically being derived from our previous block diagram only. Let us try to understand that particular thing. Now, let's say this is my temporary registers. This is Q4, Q3, Q2, Q1, Q0. So initially my Q4, Q3, Q2, Q1, Q0 are this is my temporary register Q4, Q3, Q2, Q0, right? So from here only I'm going to calculate the CRC. So this is my 0th clock cycle initial values. Initial values I'm not going to care now. Now, whenever in the first cycle I'm going to give the first data item, let's say the data item is d of 0. So whenever I'm going to give the first data item in the first cycle, that is my d of 0, what is my q4 updated value? Let's say it is q4 dash. Q4 dash is the updated value, that is my register value in the first cycle when I'm going to give d of 0. So I can see from here q4 dash is nothing but q3 XOR with d of 0 XOR with, yeah, Q3 XOR with Q4 XOR with data in, right? This you can see this connection from here. So my Q4 dash is nothing but Q3 XOR with Q4 XOR with data in. So I'm going to write down over here. So updated value of Q4 is nothing but this Q4 value XOR with the Q3 value XOR with D of 0 value. How I'm writing this? By seeing this particular diagram only, I'm writing this. And what is this Q4 dash? Updated value of the register at the first cycle. Now, what is the updated value of Q3 dash in the first cycle? That is nothing but Q3 dash. From this particular thing, I can see that Q3 dash is simply Q2. So Q3 dash is Q2. So updated value of Q3 dash, I'm going to get it from Q2 only. And what is the updated value of Q2 dash in the first cycle? So for getting my Q2 value, updated Q2 value, I need to perform XOR operation between Q1, previous value of Q1, XOR with Q4, XOR with data in. So I'm going to perform Q2 dash is nothing but Q1, Q1 XOR with Q4, XOR with data of 0. Okay. And what about my Q1 updated value? Q1 updated value is nothing but simply previous value of Q0. And what about my Q0 dash value? It is nothing but Q3 XOR with D of 0. Q3 XOR with D of 0. So this is for first bit of data, right? Now, for second bit of data, what will be my equations? So in the first cycle, my updated values of Q4, my updated values are Q4 dash, Q3 dash, Q2 dash, and Q1 dash. These are the updated register values. I'm mentioning it with dash symbol. Now, at second cycle, I'm going to provide the second data item D of 1. Now, if I'm going to provide D of 1, what will be my updated value? That is Q4 double dash. Let's say it is Q4 double dash. This register updated value is Q4 double dash at second cycle. Now, how to calculate this Q4 double dash? Again, the same equation. So instead of Q4, I'm going to give Q4 dash, previous value of Q4, XOR with Q3 is nothing but Q3 dash, previous value of Q3, XOR with D of 1 here. Not D of 0, D of 1, because this is first cycle and this is second cycle, we are providing D of 1. Now, if I carefully observe over here, the second updated value of my Q4 is nothing but, if I evaluate this Q4 dash is nothing but Q4 XOR with Q3 XOR with D of 0 XOR with. And what is my Q3 dash? Q3 dash is nothing but Q2 XOR with D of 1. So I can see the second cycle value of my Q4 register. So what is the value of this Q4 register in the second cycle is nothing but Q4 XOR with Q3 XOR with D of 0 XOR with Q2 XOR with D1. So instead of going to second cycle, if I can able to build a combinational circuit which is going to unroll my value in the second cycle itself. In the first cycle only, I can predict the second cycle value by using this particular equation. So Q4 double dash is nothing but Q4 XOR with Q3 XOR with D of 0 XOR with Q of 2 XOR with D of 1. Let's say if I'm going to give the parallel data, that is 0th bit and first bit, instead of giving serially, if I am going to give it parallelly, then I can get the second updated value, right? Initially only at the single cycle, I'm going to get the updated value of Q4 double dash. Now let's see Q3 double dash. So Q3 double dash, the equation will be Q2 dash. And what is this Q2 dash? Q2 dash is nothing but Q1 XOR with Q4 XOR with D of 0. See, the second cycle updated value, I can get it using the initial register values itself. Q1 XOR with Q4 XOR with D of 0. That's it. And let's say if I want to find out Q1 double dash. So Q1 double dash is nothing but Q naught. Q naught dash, which is basically equal to Q naught dash value is Q3 XOR with D of 0. Q3 XOR with D of 0. So this is the second updated value. So if I'm going to have Q4, Q3, Q2, Q1, Q0 content which is present with me, then according to the data which I'm going to provide, so this particular data will basically tell me what is the second updated value of Q4 double dash and uh, what is the third updated value. Up to here we have only done for first bit and second bit. Okay, so we have basically got what will be the value if we are going to give the particular data to two data items at the same time. What will be my value of this particular registers after two cycles? In a single cycle, I can find out the Q4 updated value after two cycles in a single cycle itself. And here also I can find out the updated value of this Q3 double dash in a single cycle itself, because Q1, Q4, D of 0 is already given. So like this, I'm going to perform this particular unrolling mechanism, and I'm going to compute parallel CRC. And let's say if I want to find out what is the value of my register value after three cycles. So I can find it out. So Q4 triple dash, which is equal to, I can find it out using Q4 double dash, Q4 double dash XOR with Q3 double dash, XOR with Q3 double dash is nothing but previous value, XOR with D of 2. Okay. Now, what is that I'm going to have? So Q4 triple dash is basically Q4 double dash, which is basically Q4 dash, Q3 dash, XOR with D of 2. So Q4 dash XOR with Q3 dash XOR with D of 1. And what is Q3 double dash? Q3 double dash is basically Q1 Q4 D of 0. Q1 Q4 D of 0. Q1 Q4 D of 0 XOR with D of 2. So instead of performing Q4 double dash and Q4 double dash and all, Q4 double dash and Q4 triple dash and all, you can just find it out Q4 triple dash. You're going to get directly. So how you're going to get, and if you evaluate this also, Q4 dash and Q3 dash, these are basically Q4 dash is nothing but Q4 Q3 D0. Q4 Q3 Q0 and Q3 is nothing but Q2 XOR with D1 XOR with Q1 XOR with Q4 and all. So instead of you performing Q4 dash, Q4 double dash, you can directly find out the third updated register value whenever you're going to give the third data item. That means whenever you're going to give the three data items at the same time, then what is the updated value of this register Q4 value? You can directly find it out using this particular equation. And not only for Q4 triple dash, you can find it out for Q3 triple dash, Q2 triple dash and Q1 triple dash and Q0 triple dash. And let's say suppose if you are going to give four data items at the same time, then you can find out the Q4 four dashes, Q3 4 dash and Q2 and Q1 updated values. So like this, depending upon the data item which you are going to give, let's say if you are going to give uh, 32 data items at the same time, then you can find it out directly. But here for 32 data items, you're going to have 32 registers you're going to have. So accordingly, this is CRC 32 if we are going to follow. We are going to have 32 registers, but if we are going to follow CRC 4 only, then we are going to have 4 registers only. And depending upon this, we should find out the other iterations. We need to find out like that means we need to go up to Q4 32 dashes and we need to find out the Boolean expression for that. So like this, we are going to find out the parallel CRC and we are going to perform it. So yeah, so that's about this particular session. If you like this video, please like, share and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.